Hello, this is the fourth episode in the JavaScript Bushido series where I teach QooxDoo programming. In this episode I want to create an animated background using WebGL. However, I'm not going to use the WebGL API itself, but rather use an animation from the ShaderToy webpage and render it using the high-level Three.JS JavaScript library. I will start by creating a test HTML file first without using QooxDoo. This first example can be used to add a Three.JS based background into any web page. In the second part, I'm going to use the code from the first part and create the plugin which will render it as the background in Astronos. However, before we get started, I want to go through memory lane and explain how we ended up with a 3D library directly built into the web browser. The internet has evolved a lot since its inception by Tim Berners-Lee in 1989, when he implemented the first hypertext transfer protocol, also known as HTTP. Initially, it was only intended to serve as a means to link hypertext documents together. So the contents was made up of static pages and images. Dynamic contents was only possible through plugins such as Adobe Flash. Then, in 1997, Microsoft introduced the concept of DHTML, Dynamic HTML, with the release of Internet Explorer 4. What seems now to be common practice to move some elements around and resize them to web developers' content was seen as an exceptional corner case in 1997 web development days. In 2008, the first working draft of HTML came out, and with it the beginning of the end of Flash. Two new technologies in particular caused a lot of excitement in the web development community: SVG and Canvas, the 2D context only. Finally, in 2011, Google introduced WebGL as a 3D context of the Canvas element for Chrome on all platforms. By now, in 2017, all browsers support one of the WebGL standards, version 1 or version 2. After all, 6 years is an eternity for the internet. You can count on hardware-accelerated 3D graphics rendering on mobile devices as well as on the desktop browsers. Welcome to the world of 3D. WebGL is rendered in hardware and is thus quite fast and capable. Aside from writing your own games, you can also use it like any other graphics asset on your webpage. And, for example, use it as a dynamic, uber-cooled 3D background. But before I dive into the coding part, I want to first talk about the tools and technologies we're going to leverage. Let's talk about WebGL, Three.JS, and ShaderToy. WebGL. As previously stated, WebGL became part of the browsers in 2011. In order to create a simple scene, you have to write a bunch of JavaScript and shader code, which is written in an OpenGL shading language. This language is similar to C, C++, and it needs to be compiled to eventually run inside the GPU. Three.JS. Three.JS was first released by Ricardo Cabello, also known as Mr. Doob, to GitHub in April 2010. It is released under the MIT license and became the de facto standard for web-based 3D programming in no time flat. The reason for that is that Three.js adds an abstraction layer on top of WebGL, which makes it a much more usable and powerful API. Think about the difference between a sampler and a high-level programming language such as C++. Three.js allows you to program in terms of camera, light, scene, objects, and the renderer, rather than shader code. It supports loading objects, textures, as well as the creation of basic elements such as cubes, spheres, etc. ShaderToy Wonderland. If you visit the ShaderToy.com webpage, you will find thousands of cool demos, including some small games, all written to utilize the graphics card hardware accelerated shader pipelines. What I wanted to achieve in this episode of teaching JavaScript was to add one of those toys as a background to Astronos. ShaderToy and Three.js combination. In order to marry those two, we have to know the data required for the ShaderToy samples to work, and create an appropriate interface for them in the shader itself, so that Three.js can take on the rendering. You see, ShaderToy creates all its magic on a 2D plane and displays the texture then accordingly in the 3D context. Three.js is all 3D through and through. So let's first build our vanilla HTML page to run ShaderToy samples standalone using Three.js. Okay, so let's first create an empty HTML page which we are going to use to build out our little standalone example. So here we create a new document and let's call it galaxy.html and click OK. And then we want to open it as source and have it in our IDE. Okay, and I have prepared a little code snippet here so that it doesn't take too long. So let me first copy that code over here and then we can go and talk through it. So we first create a standard HTML page which has a head. Inside of this head we load the Three.js libraries and we give it a title called Galaxy. So the background of the HTML page itself should be black and it shouldn't have any margin and the scroll bar should be hidden. So inside the body we have one container exactly, and this container is then used later on for the Three.js renderer. Here this is a utility function which I'm using to load data dynamically. So my goal is to get the source code for the renderer, for the shader, from ShaderToy itself and then store it on disk and dynamically load those into the JavaScript application. So that's what this load data function does. This load data functions in turn calls fetch file, which executes the XML HTTP request, also known as HX call, to the backend, and then once it receives the response, it calls back this callback function here and adds it to the list or to the response. And once the list is empty, it calls back the callback function. So we can use that, as I said, to dynamically load the data from disk. Then next we create the initialization function for Three.js, for which I also have some code here. We define a couple of global variables in JavaScript for the container, the camera, the scene, and the renderer. So in the initialization function here, the first thing we do is we get the element by ID, which we have defined up here, which is this div container. And then we create a clock, a scene, and a camera using the Three.js library calls. For the camera we assign it a C position of 1. Next we create a geometry, a plane geometry in this case, and define the uniforms. The uniforms now are used to communicate with the shader pipelines, so that's what's going to happen and what enables us to communicate with the ShaderToy sample code itself. And then we create material here, and for this material we actually do need to pass in the uniforms. We need to pass in the vertex shader code, and we need to pass in the fragmentation shader. Now if you see, the fragmentation shader that we get from ShaderToy requires some additional code before and after, and I have created a function called boilerplate where we retrieve the beginning and the end for this. Then the next step is to create a mesh, add the geometry and the material together, and add this mesh to the scene. So the renderer is then generated as one of the last steps for Three.js, and the final thing is for the container. For the DOM element of the container, we append the child of the renderer DOM element, which is dynamically created by Three.js here. And the final two lines in this function basically will handle the onResize event inside a browser, inside a window. And to start off with a proper size, we call this onWindow resize function manually. Now the onWindow resize function has not been written yet, so let me do this. It's actually a very simple piece of code, and we can just copy it over from here. It basically takes the uniforms which we defined here and adjusts the resolution, the X and the Y value to the inner width and height, and then it also sets the renderer size to the width and the height, and that was it. So very simple, straightforward. Next, let's handle the animation of the actual 3D code. So for this we have the animate function, and this function call is specific, or is a built-in function for in the browser, which requests the next frame whenever there's a time slot available, so that in the worst case scenario the browser will not completely lock up. It will just request the next frame whenever it has resources or time to do so. And the next thing after we request the next frame, we do the rendering, and the rendering itself is also just a very small line. We pass in the global time, we get the delta since the last read from the clock from Three.JS, set this to the value in the global time, and then we render that scene using the camera at hand. Now here next is where we actually call the load data function, which we defined at the very beginning. The load data function will load the information, the vertex shader and the fragment shader from the disk, and then call the init function that we defined here to initialize the Three.JS library. And then finally we will animate this whole animation by simply calling this function once, and from there on forward this request animation will take care of this animation function to be called continuously. And finally, let's take care of our boilerplate code, the function, and for this as well I have created a template and I copy it in here. So for the first part, for the beginning, we will simply add this piece of JavaScript, the fragmentation shader here, and this code is required to actually make the ShaderToy sample work inside of Three.js. So it's basically defining the global variables, global time, channel time, mouse, etc., etc. And for the post fragmentation shader, we define the main function, set the background color or the clear color, and then we call this main image function. The main image function is what actually is the contents of the fragmentation shader itself. We pass it these two attributes, and then we come out, and that should do the trick. So that's it. That is the whole code that you need to port one of the ShaderToys to Three.js. Then next we need to get the sample code from ShaderToy that we actually want to use as the background, or in this case as the background of the window. So this is the one that I think would look really great as a background for astronauts. You can hear it actually has some music. Let's close this for a second. So we go ahead, we select all, Control A and then Control C to copy it in the background, and then we create a new file here called fragment.shader. Save this, and then we open this here and we copy the code in here. Let's try this again and copy the code in here, and then we save this up. And the last file we need to add in is a new document which we call the vertex shader. .shader, and this is basically boilerplate code that should barely ever change, and it looks something like this here. And then we save this as well. One small adjustment that we have to do in the fragment shader here is, in this case, we call it global time. Save this as we define it in the uniforms up here as global time. So now with that done, and with the with the boilerplate code which is being added to the fragment shader, we should be able to simply click on here, and as you can see, the animation shows up as the background to this web page, or any web page for that matter. And in the final part of this episode, I want to briefly go through how this can be leveraged to actually display the animated background in Astronos. So for that, I have written the plugin.js, which uses the code that we developed in the first part of this episode. We go through the header, we define the class name, and we derive this class of the qxcore.object, which is a QooxDoo object. Now, in Astronos, every user's background can be different, so the background that you see here is actually part of the user object. So we'll check if we have a animation already running in the background. We want to dispose of it. So if I start this plugin, you will actually see that this background will disappear and it will be replaced with the galaxy that we created previously. And then we have the same variables we had in the initial example: renderer, camera, scene, and clock. In the destructor, we want to free the memory, we want to remove the resize listener, and we want to clear the Astronos background div again. And then we just have the same type of functions here. In the init function, we load the Three.JS JavaScript. Once this is loaded, this is asynchronous, so once this is loaded, we actually load the shader. And the shader loads the vertex shader and the fragment shader using the same function as we discussed before. Once this returns successfully, the post-init function is being called. So in the post-init functions, we add the listener for the resize event. We initialize the WebGL function, which again takes the vertex shader and the fragment shader, and we set this initialized variable to true, and then we render the first frame. So when we render the first frame, we need to have a renderer. We need to make sure that we actually have a animated background set. We render the scene based on the camera, and we adjust the time based on the clock last time. So one adjustment here is I slow down the whole animation by a little bit, and then instead of simply calling the next request animation frame, in order to save resources, what I do is I create a timer which is called back after 100 milliseconds, and then after 100 milliseconds the renderer will be called again. So that will slow down and it will save resources in the web browser. The resize function is basically identical to what we had before. Init WebGL is the same, it's basically identical as what we had before. What we define here is the clock, camera, the scene, the geometry, uniform, the material, then finally the mesh, which we add to the scene, and the renderer. And then we set the size and we add it to the DOM element. And here we have the function, the boilerplate function, and that's pretty much it. The last line in this JavaScript module is to actually instantiate this class that we just created up here, and then once this is instantiated, it will replace the background and we should see it working. So now if we start this, we'll see that the background is being pulled and we are finally able to see the the WebGL background, which is coming straight from ShaderToy. This concludes the 4th episode in the JavaScript Bushido series. Thank you so much for watching this video, and I hope that you found it informational. You can find a link to the source code below. You can also leave me a comment here or visit my blog under softwaresamurai.org, where you will find more information about JavaScript, QooxDoo, or programming in general. Also, please let me know if there is a certain topic or problem that you want me to talk about in a future episode. I'm always open for suggestions. I hope to see you back soon.